Alrighty. Minimum deletions to make a string k special. You're given integer word and integer k. We consider word k special if the frequency of word at I minus the frequency at word at j is if the absolute value of that difference is less than or equal to k for all indices I and j. So that means I think for every character in the word, every character in the word is at most k frequently as that is that the difference between the range of the frequency of the difference between frequencies between any two characters in the word is most k. So if A is like maybe 5 and B is 6 times appearing in the word, then and K is 3, then that means that's fine. K is 4, then that means that like any two characters can be at most within 4 of each other, the count of it. Okay. Here, if the frequency of X denotes the frequency of character X in word, and absolute value Y denotes the absolute value Y. Yep. Return the minimum number of characters you need to delete to make it K special. Oh, okay. This seems pretty simple, actually. You just need to, okay, so an example here, K is 0, so you need to make sure that every frequency is the same, and you need to delete the characters to make that so. So looks like A is the most frequent, and B and C are less frequent, so you would delete the B, C, and this B, this C, and this B, and make everything A's, or everything 4 frequent. You could also maybe make everything like 2 frequent. Have a frequency of 2 if you delete A's. In theory, if that might have been better. Here, everything within range of 2. So you delete A, the B, those are 1s. Well, yeah, you delete A, B, and you left with C and D. That's looks like to be roughly the same. Yeah, C and D is 3, and C is 3, and D is 4 frequent. Here, you would need to delete this B, and then your A. Okay, this is an interesting problem. Because you could, in theory, delete things. Well, okay, let's see how this goes. So first, I think I need a frequency counter. Frequencies, and let's say counter of the word. Is that gonna give me? Is that gonna give me what I want? Yeah, I think so. And then I think I'd like a sorted version of it. Once I have the frequencies, I guess I don't care about the characters themselves, I just care about the counts that I'm dealing with. The counts and how frequently those counts occur. Like the count of 4 occurs once, the count of 1 occurs twice. Okay, so I think what I want to do is I want to have a track counts and frequency of counts. Counts being the original frequency. Oh gosh, this is. Frequency and counts are very synonymous. So I'll just give an example here. Example, let's say you have A, B, C, C. This means that you have counts of 1 appearing twice and 2 appearing once. Let's say A, B, C, C. So A and B appears once, and the count of that is 1, and the frequency of that is 2. And then C appears 3 times, so the count of that is 3, and the frequency that something that appears 3 times occurs is once. Counts and frequency of that count. Okay, so for every letter in the original counter, actually maybe I can call this counter. It's too many counts. I want to, I'll keep this, I'll call this, I'll call this mapping meta count. And this is a mapping dictionary. So for every letter in count, I guess it's every letter, comma, frequency, encounter, counter.items, meta count of this frequency plus equals 1. I guess this should be a default dictionary of integers. And then I'll just print out this to make sure it's working. Oftentimes there is something stupid that I do. Let's go with A, B, C, C, C. Okay, yeah, so the frequency 1, or the count 1 for A and B occurs twice, A and B. That's 3. BC, those counts are 1, so frequency of that is 2. No, sorry. C 1 is 1, B is 2 counts, frequency is 1. A is 4 counts, frequency 1. Okay, so that looks fine. And now I need to determine, let me think. I need to determine what to remove. So if I were to remove, I probably should be removing the least items. No, if there's a bunch of ones, like the count is 1 and the frequency of that is like 10. If I were to remove that, that takes 10. I guess the weight of things to remove depends on, marginally, I can remove like the highest frequency or the lowest frequency. Okay, so I'll say counts. I can remove the highest count or the lowest count to get everything within the range of k with each other. Marginally, the cost of that would be the count times the frequency of the thing, cost times the frequency to get the things removed. So for instance, here, like the most frequent thing that's there is A, which is 4. So if I want to remove all the things that are frequency 4, then I would need to remove 4 things, versus the lowest thing is 1, so I would need to remove. Although technically, that's not quite right either. If I remove 1A, the count of A's becomes 3. So the cost of removing the the cost of removing the top item is the number of counts within it. What is the frequency actually? Okay. So if there were like two things that had 4 in it, let's say A, B, B, C, 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 D, C, 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 D, D, D. So here it's like 2, 2, 4, 2. There's 2 letters that have a count of 2 and 2 letters that have a count of 4. If I wanted to remove the top end, I can remove 2 things, the C, the fourth C and the fourth D, and that would make this into a 3. If I want to remove the bottom end, I would have to just remove the bottom end. I'd have to remove it completely. I have to remove 4 things. Because I can't just increase this, but I can just decrease this to like 3. Okay, so kind of cost of removing lowest count should be the count times frequency of that, and the cost of kind of decrementing the highest count is going to be the frequency of that. So let's just like remove 1 letter from each thing that has that frequency. But will increase the frequency of second highest count. So for instance, if this was, let's say there was 3 E's here, so 3 appears once, that would be now 3 if I want to remove this thing. If I want to remove two things that appear 4 times, that would now become 2 extra thing that appears 3 times. So it become now 3 count of 3, like E, D, and C would all be 3 at that point. Okay. That still doesn't quite determine what I want to do. So if let's say the K is like 0, I would need to get everything to the same frequency, either by removing the lowest ones or removing the highest ones down so that's the same as the low. What is the optimal way of doing that? I don't think it's a greedy approach. It's definitely not a greedy approach. And it's definitely not. I consider greedy approaches as kind of like every time you do something that's marginally, incrementally moving towards the goal, like removing the top and bottom without really considering the second or third thing that you have to do, it's still always correct. But it's not always correct to just maybe like remove the lowest because it has 1. Actually, yeah, because the marginal effect of removing the top is not the same. Because once you remove the top, it changes the cost of removing the second highest. Or is it not? Maybe it is the greedy approach. You kind of know how much it costs to remove the bottom. You kind of know how much it costs to remove the top. And you just remove one or the other until it's within K, whichever the lowest incremental cost of removing that thing is. Okay. So I guess I backtracked. This is maybe a greedy approach. so this is attempt. We'll see if this works. Remove either the lowest count or highest count, or like highest count being altering. Each step to get while range of low count, while range of low count, low to high is greater than k. Everything needs to be k within k, right? Okay, so do I need a sort? Do I need a sort counts? If I were a sort counts, then maybe this shouldn't be a dictionary. Maybe I need to convert the counts dictionary into an array of tuples so that I can sort it. Array, or maybe even a queue. Yeah, maybe a queue. Double-ended queue. So here I'm going to convert dictionary to double-ended queue of tuples where it's count and frequency. Okay, so for every count frequency in, actually I think I can just use a list comprehension here. Let's say I have tuples. Well, that's just a horrible name. Count array. Maybe I can just call meta count again. Okay, meta count is now going to be converted into tuples of count and frequency of that. So meta count of this count for every count in the meta count now. And then I'll sort it. And I'll just make sure this works. Okay, so yeah, 1 1 2 1 4 1. Okay, that looks fine. Okay, and then for every index, no, for every wait, this should be a deck. I'll call this my double-ended queue. It's gonna be a deck based on this meta count. Okay. So while the front tuple and while the front tuple, which is going to be deck at 0, and the frequency of that is going to be the first element is, well, okay, the deck, the last element, the most frequent thing. Minus the first element if the range of that is greater than k, then consider removing either the front or the first or that last one, right? So how to do that? I guess there's only 26 letters, so the frequency can only be eeks. I'm just considering now. Creating a bunch of tuples for like, yeah, that's a lot of tuples. I might want to convert this into an array rather than a deck. Yeah, maybe it should be just an array. Deck is a little fancy. So I'm gonna have to add and subtract. Okay. Yeah, this is just too fancy. Answer is equals 0. I think this should just be an array. Because 10 to the 5th, I can just make this into. Okay, let's try it for now. Yeah, let's try this for now. Answer equals 0. The low and the count. The low count and the low frequency is going to be equal to deck at 0. The high count and the high frequency is equal to deck at the last. If the cost to remove the low cost is going to be the low count times the low frequency. And then the high cost is just the high frequency. Which one would I prefer though? I would generally prefer to remove the low because the low doesn't have any secondary effects. Oh. I prefer to remove the low. I wonder. Okay, if the low cost is less than the high cost, then removing the low is just removing the left tuple. Otherwise, if you remove the highest frequency letter tuple, then you need to modify the last or create a new last. So if deck, I guess I need to pop the last. So deck dot pop right. I think it's just pop left and pop. Yeah, pop is the right end. Okay, so if I pop the left or pop the right, then now if the new last tuple has a count that is equal to 1 minus the current high count, then I need to modify it. Add like this thing, right? I would need to, if the current high count of 4 is 1 more than the second highest count, then how much should that increase by? It should increase by the frequency of the high count. Then I should say deck.pop again. And the frequency, let's see. Other frequency is going to be I pop it and other frequency, I don't care about the count. Okay, so the other frequency is popped and the high frequency is increased by that amount. And then once I pop that, now I need to append onto the deck the tuple that is the high count minus 1 and high frequency now. High frequency, yeah. So also this is the cost, the answer is going to be increased by low cost times high low count, or low cost I guess. And here the answer is going to be increased by the high cost. I think this is correct. So I remove the top tuple for 2, and then if the second highest tuple has a count that is 1 less is equal to high count minus 1, then I look at the frequency of that, which is currently 1, and I increment it to the frequency of the previous high, which is 2, so it becomes 3. And then I pop it, pop the 3 1, and then make it into and add like 3 3. Otherwise, if it doesn't match, then I just make a new one. So, all right, I think I'll try this. This might be slow, but it might be correct. Okay, somewhat correct. So here, interesting. This thing removed 3. I should just remove the B. What the fuck? The low cost should have been 1, the high cost should have been... no, the low cost should have been... I should prefer the low cost. Okay, there we go. Test case. So this thing's moving 5. So the low, let's see, that is 3 1 and 9 1. I need to get to 5. No, I get within 1. So, I see. No, I don't see. So it's within 1, so it needs to be like 3 and 4 or 8 and 9. Well, it can't ever be 8 and 9. So if I remove the top end, it goes 9, 7, 6, 5, 4, 3, 2, 1. Or if I remove the bottom end, it's just removing 3. I see, I can't do the greedy approach, I guess. Ah, shucks. So if I remove the bottom end, it's 3. If I remove the top end, it's if I remove the top end, it's gonna be 5. If I remove the bottom end, it's 3. If I remove the top end, it's 5. So incrementally, this doesn't work. So just try and get to 1 at a time. Get to incrementally, it doesn't work. What? What? What about I wonder. I wonder. What if I tried to just compute the cost of removing some range of values? Like removing the bottom 3, bottom 4, bottom 5. So the cost of removing bottom most is 3, and the moving cost of moving bottom 2 is like everything that's frequency or count 3 or count 4 is also 3 because there's 0 4s. So if I kept a cost tracker for removing each level, I kept a cost tracker removing each level, the highest level, and then this, this 2 highest levels, 3 highest levels, and I would be finding the minimum, the cost overall of getting it within some range. Where, let's say the k is the start of the range, then it'd be the cost to get it, the low to be k, or unless k is wrong. Let's say p is the start of the range. The cost to get all the low frequencies to be up to p, to remove all the low ones up to p, and then to remove all the high ones down to p plus k. And then I just do that for every combination. That'd be kind of linear time probably. Interesting. That could work. So I think I'm gonna scratch this, as pretty as it is. I think I would like an array of this. So the meta count is fine. Actually, no, not fine. I think I want to just know what the low and high are. So once I have my dictionary, so low frequency, let's say the low frequency is currently something like outrageous, like the this length of the word. High frequency is 0. Actually, maybe maybe I don't even care. I'm gonna just go ahead and okay, I'm not gonna care about space here. I'm gonna say n is the length of the word, and I kind of still care about where I start though. Meh, do I? Maybe not. Okay. N is the length of the word, so that's the highest frequency can be at most, no, whatever. Let's say I have a meta count array that's actually just going to be 0 times the length of n. And again, this is mapping the frequency to the count to the frequency. So for every letter and frequency and counter items, meta count of this frequency, I guess 1 is going to be index 0. No, 1 is going to be index 1. No, 1 is going to be index 1. Okay. Okay, 0, 1, 1. Okay. I think that's what I want. Yeah. Just something straight up flat array. No dictionaries involved here. Okay. And then I'm going to say this is going to be this is remove low costs is going to be an array, and then remove high costs is going to be another array. Remove the low cost is I'm going to iterate through each count in in the range of n. If n is a one-sized array, that's not going to work, is it? It's going to go out of bounds. N is a one-sized array, that's going to go out of bounds, isn't it? It's going to just crash right here. I think it might be n, yeah, n, it should be n plus 1. Okay, so for every count in the range of n, I'm going to have a summation move costs is going to be 0. Remove costs to remove this count is going to be incremented by the count of this thing times the frequency that occurs. And then I'm going to append that to remove costs, remove low costs. This is costs cumulative, is that how you spell it? cumulative. Yep. Cost to remove low counts. So if the low count is 1, so there's a low count of 1, 2, and 3. This is how much it costs to remove 1, how much it costs to remove 1 and 2, how much it costs to remove everything that's that and below. So that appends to that, and then I'm going to do the same for the high costs. Or have to traverse backwards, or append backwards, or append and then reverse the thing. Remove high costs. So for every count in the range of, this should be n plus 1. N plus 2. So if it's 1 is the length, the highest count could be 1, and I would need to be, this might be n plus 2. Is that going to go out of bounds? I feel like that would go out of bounds, no? 2 is stored in index, 1 is stored in index 1, n plus 1 of that point would be 2. Okay, I think this is fine. Alright, move high costs of, so I want to iterate through it backwards. I want to iterate through the meta count backwards. So if we count from n to 0, I guess I probably don't mean 0, but I guess I go back to remove cost being 0. So this would mean I would look at the frequency, right? So remove costs plus equals the meta count at this count, and then I would need to change the meta count for the count plus count minus 1. Okay, if I do minus 1, I can't go down all the way. Probably don't want to go down all the way anyways. So count minus 1 plus equals the current frequency. Is that right? I think that's right. And then I'll append this to remove high costs. I guess maybe I can just make this into 0 times, there's going to be n plus 1. I'll have to do a reverse later on. Remove high cost at this count is equal to the remove costs here. And let's go ahead and check our work. Okay, so what do you have here? I think I need to know what my meta counts are. Okay, so there is 1B, so that's count 1, frequency 1. There's, 1C, and then 2 B's. So that's count 2, frequency 1, and then there's 4 A's. That's count 4, frequency 1. And then the cost to remove the lowest one is 1, so that's removing 1c, and then cross remove the two lowest counts is going to be moving 1c and 2b's, so that's 3. Cross removing the three lowest counts, in this case count of 1, 2, and 3, but there is nothing that appears 3 times, so it's still 3, and then removing the 4 lowest counts, which is 1, 2, 3, and 4. It's removing all 7 letters. Okay, so that looks fine. And then the cost of removing the top count, which is 4, making it 3, is just 1. And then if I want to remove the top 2 counts, so remove everything that is count 4 or 3, I have to remove 2 A's, so that's 2. And the cost of removing 4, 3, or 2, I have to remove 3 A's and 1 B, so that's 3, 4. And then the cost of removing, okay, that looks fine. Alright, I mean, I can verify it with one more case, I guess. Okay, so moving low 1 is that, yeah, and then if I remove all the A's, then it'd be another 6, so it's 7. And then moving the top A is 1, so then 2 A's, then 3 A's, then 4, yeah. So this looks good. So for every possible index, so it's the sum of these two is the overall cost actually the sum. Okay, so for every count in the range of n minus k, or it could be n plus 1 minus k. This is important. I don't want to go out of bounds. I think it's n minus k. The cost to get everything within range of k of count is going to be answers equals 0. Actually, this should be something really high, low infinity, and then answers equal to, actually, cost to get all counts to be in range, actually, it'd be low count to low count plus k equal to move equals move counts below low count and counts above low count plus k. So cost is equal to remove low cost of low count minus 1. Low count minus 1. Yeah. It's like that goes out of bounds, no? Maybe it needs to be starting with 1. Because you really can't remove low count of 0. There's nothing to remove, right? Plus remove high cost of low count. Oh gosh, I'll just say low and high. Low minus 1, low plus k, low plus k, or low plus k plus 1. So What should it be? If you want to have k be 0, which k could be 0, so the range is 0. Yeah, this is k plus 1. Get the sense that it should be k plus 1. Oh. If this was something where I couldn't actually run it and actually test it, then I would think harder about the logic, but I'm just gonna see what works. And then answer equals the min of the current cost and the previous answer. Okay, so null is definitely not working. If k is 0, what does that mean? So you don't need to remove anything. So why do answer is infinity? I see. I guess if you don't have to remove anything, then return 0. Okay, let's see if that works. Wrong answer. Fair amount of cases. Okay. So k is 3. This is another case where you have to remove 0. Maybe this thing just fails on trivial cases. That doesn't seem right. It shouldn't fail on trivial cases. Print, remove, low costs. Did I already do this at some point? Nope. Cost 0 to move, low cost, and then it costs 11 to move. Guess there's 11 characters here probably. And then cost 1 to remove the 11th. Okay. So should be 0. So it should be something like I remove maybe this should be n plus 1. Another high, like removing absolutely 0 there. Yeah, I think this should be n plus 2 then. Like there should be a possibility that you don't remove anything from the high end. And this thing assumes that you want to remove at least one thing from the high end. Just like it's possible right now, it's definitely possible to remove nothing from the 0 end because the 0 end, low end is just 0, 0. Always. So n plus 2, n plus 2, n plus 2, n plus 1. Okay. Whoa. No, why doesn't this work now? Oh, yeah. This doesn't work because I don't go up high enough. There we go. And I probably should remove that printout. Okay, let's see if the printout was what is slowing this thing down. I don't think this is very, I think this is pretty fast. Oh man, it is so slow compared to other people. I don't print out anything, right? Yeah. It is so slow. Do. Make your frequency. Yes, you can do this probably in one pass. Right? Can you do it in one pass? Rather than making a low cost and then a high cost. Right now it's like 3 passes. So for instance, what would you do? You would go remove the top, remove the bottom. I guess you could do 2 passes. 1 pass to remove the top, and then once you remove the bottom, you already have the top to compare it with. Okay, I don't think that's, that might improve it by a third. I'm not sure it improves it that much though. Huh. Like this is order of magnitude slower, like 10 times slower than 46. Feels like am I sorting it somehow? I'm sorting it. So I guess I create the counter. Do I even need to create the counter? I do. Create the counter, and then I create the meta count, converting the meta count. Converting it to a dictionary. Actually, I think this is kind of stupid. For every letter in frequency, I think it's just for every letter. I guess it's not any different than if I just went, actually for every frequency. Let's see, what is this, what's going on here? Each letter has a frequency. So A is 1, B is 1. No, that's fine. Okay, so let me do 1 pass for the high count, and then I'll just do 1 pass for the low counts without creating the remove low costs. So so then the second pass is just for the low. Remove low costs. It's going to be just a single variable. And then for every low, actually, Okay, so remove low cost is a single variable for the cumulative cost removed all the lows up to now. And then I say the cost is whatever the remove low cost cumulative effect is, plus moving high up to that point, low plus k plus 1. And then answer is minimum. I wonder if I can break at a certain point. I bet it's the fact that I go too far in how much I have for the array. Okay. I think this is an improvement, but I think there's probably a bigger improvement to be had by making the array smaller. Probably it's like order magnitude's too big. Oh boy. Oh boy. Making code not work. Huh. Oh, whoops. I forgot to actually do the remove costs incrementing. Remove low costs is incremented by the current low times the frequency of this low. Still not correct, still not correct. Why wouldn't this seem correct now? Move high costs. So this is 7, where it should be 3. Too high. So it should be low, move low costs. Meta count of the low. Count times the meta count of the low. Where low starts with 1. 1 times the... Okay, I just need to see what's going on. Then 7 output. So here's like 7 plus 0. And then here should be like, at some point this should be 4 plus move high costs. So it should be 0 plus 7, or 0 plus 0. Should be 0 plus... Okay. 1, it's where it's 7. Index 1, it should be removing the low cost of index 1 plus the high cost of index 1 is 7. Yeah. Removing the low cost of index 2 which is okay, the lowest one, moving the lowest cost of one is 3? Really? It should be 1 times 1, I think. 1 times 1. Is my meta count not low? Somehow my meta count came wrong, I think. Yeah, my meta count is wrong now. What did I change here? Meta count. I don't think I changed anything here. Word n+2. Remove low costs. High costs initially is count, remove costs, count times meta count, count times meta count at this count. Plus low times the meta count of the low. Let me go ahead and print remove low cost. Yeah, it should be 0, 1, whatever. Yeah, the meta count is oh man, I'm getting confused. What's going on? What is this thing doing? Meta count is 33211. Frequency of okay. Time for some cleanup here. Wish I could have like two separate code things I can run. Okay, let's go here. And let's just look at this portion. Like, is the meta count always this weird? What? Will the meta count change? Okay, the meta count is fine there. Meta count is 0 times n plus 2. Meta count of the frequency plus equals 1. Oh, I see. I did some. Well, I did the calculation of the remove high cost. It actually changed the meta counts. I see. Okay. So if I want to do that, then I need a separate array. I see. I see. Remove high cost. What should this be? What should this be? I guess it's the sum. It's the sum of the characters above it. The sum of the characters above a certain level. Okay, so say, let's go ahead and say for high, just to make this clear. Actually, wonder. I guess I just don't need this really. I don't need to add it. Do I need to add it? So if it's the cost is 2, then you remove 3 characters. Then if you want to remove, yeah, I guess this is all the same. I don't think you need to necessarily do it twice. No, you do need to move it twice, so you need to actually add it. So if you remove once, so move C and D, that's 2. And now the next one you need to move C, D. I think the remove cost is I think the remove cost is actually the current remove cost plus the current meta count at this high value. So if you remove the top 2 from 4, so you remove a D and a C, so you remove 2. Remove cost is 2, and then the next time the remove cost is additional 3. Two plus 1 is 3. that point the remove cost is now 5. Then the next time you don't need to remove 5. No. Okay. Move. Maybe you do need to modify. Okay. All this is just stupid. Just to avoid the fact that I want to make another array. So what I do want is to modify the meta count high. Okay, so copy meta is going to be meta count copied. And then I modify it here. And I'm going to say meta counts is now back to the copy. And then I do the low stuff. Okay, the count is now back to normal. Okay, the low cost is at 1, it costs me 1. And then at 1 the low cost is 1. And to remove the high stuff it's another 4. The remove high cost is probably correct. Cost low plus k plus 1. Is kind of off by 1 generally. Cost to get all counts to be in range low count to low count plus k. Yeah, so it was actually remove low cost of k minus 1, right? Before. Remove low cost low minus 1. So actually it needs to be the previous low amount. So the low amount before I increment this thing. Yeah. Okay. Yeah. So let's stop printing out stuff. Nice. Okay. Alright, getting back to square one. Yeah, still too slow. I'm guessing if I were to print out my meta counts, it's just too big. Probably what I need is something much shorter. And iterating through the actual bounds that I'm dealing with. Okay, so I think I need to go with what the high frequency and what the low frequency are. So Uh, I think I need to know low frequency. Low frequency is, let's say, N. High frequency is 0. And then low frequency equals the minimum of low frequency and the current frequency. And high frequency equals the maximum of high frequency and the current frequency. And then I think this is probably fine. It's in the range. So this is probably going to be high frequency plus 1 down to the low frequency. Might be low frequency minus 1. Low frequency minus 1. And then the low goes from 1 less than low frequency. Or the low frequency itself. Up to what? Up to the high frequency plus 1 minus k. Oh my gosh. Why? Well, I shaved off half my time. Still too slow. Am I just making this too complicated? I have my frequency going through just N. Yeah. There has to be like maybe a one-pass solution to this. I mean, the one pass has to be at least if there's counter. I'll see how you can get around using counter. Low frequency, high frequency. Meta count, remove. So for every high frequency, you kind of get the summation of removing the high values. Maybe this copying is not great. You do it so that you know everything within range K. Guess you could sort your tuples. Copy meta count pretty high frequency +1, so you also get to 0. Remove costs. I guess you. Okay, I mean this should be able to do that. Pretty sure, yeah. Meta count of high -1 plus equals move cost plus equals meta cost count meta count. And then you take your next one and you increment it again. Remove costs is incremented, and then you modify your smaller count by your current count, not by your current cumulative costs. What if you did something like so you increment by the current cost, modify the next cost, and then you immediately change your current costs back to what it was pre-modified. Meta count of high +1. All this to avoid copying one array. Look, doesn't quite work out correctly. The count of high subtracted by. So change your smaller one. Okay, this is I don't know. Okay, I think this is one where I'm actually just curious enough to say fuck it. What is the thing that I'm missing here? What is the thing I'm missing? Accumulate. I don't know what that is. Collections counter. So you get your counter. You get the smallest count. Smallest equals counts at I. Get min deletions. Get min deletions at I. So you have a function where it looks like it's, why is there a subfunction here? What? results smallest Gitman deletions of I plus 1 is the recursive function. That's really weird. What? Okay. Moving on. You have your counter. Answers infinity. Huh, I didn't know you can do that. Pre 0 for I and enumerate count. Temp is pre for j in range I plus 1. The length of count. The difference is the absolute value of n minus capital J. This is a horrible way to write an if statement. What the fuck, man? Like, who taught you how to indent? Or who didn't teach you how to indent? I guess that's, can't really ask that question, but this person should learn how to indent and use new spaces. Oh. I mean, I don't know. IDK. Difference is greater than k. Temp plus equals difference minus k. So it's a nested for loop. It's kind of a nested for loop. You have your counter. You have your low frequency, high frequency. Get it from finding it within here. Make a copy of the counts. Find the commutative high cost. I mean, this should be one pass. Should be pretty darn quick. I really wonder if this thing is actually slowing down that much. Making a copy of the... There's no way. There's no way it should make it that much slower. I mean... 700 test cases. Each test case is taking a couple milliseconds. No, not even that. 0.2 milliseconds. Like that. Alright, whatever. I'm done. I am done. Should this ever be float infinity? I don't think this should be ever float infinity at this point. Fuck. It is still float infinity. Really? I guess if the low frequency. Why is this gonna go infinite? So it never hits. The cost is what? The low frequency. Actually. ever run the for loop? Is that it? Probably not, right? Yeah, so if low frequency is equal to high frequency plus 1 minus k is low frequency is less than, is greater than or equal to high frequency. Okay. Alright, I'm going to accept this rather unoptimal solution, but it's been improved. Summary. So in general, I really actually didn't fully understand the other code samples. Create an array, kind of like a prefix sum array, but a I'll say a suffix cost array. That that has the cumulative cost of removing removing the highest counts in the word. So here, I guess even before this is, use counter to find the frequency of each letter. Convert that information into a meta count array that has the count and the frequency of that count. So example again is, let's say it's AABB or AABBCCC or 4 C's. This is going to be a meta count of two things that are 2 appearing, and then one thing that's 4 appearing. And then create a suffix array that suffix cost array, suffix being ending cost array that has the mu cost of removing the highest counts. So for instance, in this case it'd be something like removing the highest count of 4 would be 1, and then removing the second highest count of 3, given that you removed one to becoming remove one of the C's to become a 3 count, that's going to be 2. And then removing something, removing the highest 3 counts, so 4, 3, and 2, you need to remove 3 C's and 2 B's, so that'd be, or 3 C's and A and B, so that's like 5, and then removing counts of 1, 2, 3, and 4, all of those, that would be all the letters basically, so it'd be 8. And incrementally it's the frequency of that count. The frequency of that count determines how much you need to remove. So because there's only 1 4, then you need to just remove 1. At that point, that increments how many things that are 3. 3 becomes, the count of 3 has a frequency of 1 at that point. And then removing the count of 3 is another 1, so that's 1 plus 1 is 2. And then at that point there's now 3 things that are 2 frequent. A, B, and C are those 3, and then removing those 3 things to make it count 1. Now that's 2 plus 3 is 5. And then from there, go through each possible low count and um, and on the fly find the incremental uh, or the commutative cost of removing low counts, which low count is just below count the count times the frequency, moving every letter of that low count, and then summing those up or keeping a commutative variable, and adding low count or low costs plus high costs at the count plus k plus 1, give or take. So I call this the remove high cost array. So you find basically how much it costs. So for instance, let's say k is 2, and you're going through all the possible low counts. You're saying, what if I remove everything that is of count 1 and below, and then everything that's count that is so below 1 and then bigger than 3, or remove all the counts of below 2 and bigger than 4, so that everything now is between 2 and 4, and you know, find the minimum of those costs. All right, so I mean that's this little here. Costs is going to be remove low cost plus remove high costs, and then you increment your remove low costs, iterate through. This is open to go through each element of n. What's n? Of n, where n is the range of frequencies, which is going to be at most k, where k is the length of the string. So it's going to be at most maybe O of k. Basically, this is going to be O of n as well, for creating the low cost or move high cost array.